Hey everyone, I'm Yash, and I'm learning British accents. I'll try. I'm just joking. Okay, so today we will talk about the securing the modern software supply chain security, and we'll try to give possible information what it is and how we'll be implementing it and why it matters. So I'll talk about ourselves. I'm Yash, developer advocate at DigitalOcean. And with me, I have one of my co-speaker, awesome co-speaker, Yash
Yeah,
Pimple, software engineer at Chainguard.
Chainguard.
So, okay, so let's start with this simple diagram. So we have seen that the applications are getting started complex when we start coding them, right? Previously, 10 years ago, 20 years ago, the application used to be a simple website with just simple application, maybe JS file, maybe HTML file. But nowadays, the applications are getting more and more complex, especially for the backends, especially for the Golang services. We started using dependency to make sure we reuse our code. But later on, we find out those dependencies are also using other dependencies, right? This is what we call our transitive dependencies. And it becomes a dependency hell when those other dependencies are also using the other dependencies. So it can become very, very unsecure in our modern software supply chain. So let's move.
So if we saw the past slide, if we see there, we tend to have transitive dependency, which we call as dependency hell, where we make use of one dependency and it in return use many other dependency which are not that good with respect to security, or they can have some cryptographic packages or library. Consider an example where we are using a Golang package, and it tends to use the cryptographic library which is not compatible to FIPS, or it's not compatible to the build system that we are working on. That's why to consider or to fix this particular problem, that's where the software supply chain comes into picture. So if we see this particular diagram, we tend to have a source code. Everyone over here tend to build packages and software with the help of their source code. They use dependency, they build it, they draft the package, and they run it into a production. But the critical stage where everyone should focus on is a dependency, because dependency are way more fragile as compared to the entire software, because we are not sure from where the particular packages or from where the particular libraries are coming into a whole build pipeline. And dependency also tends to have a smaller diagram, I can say, where we tend to build or make use of the same packages. And that's why software supply chain security matters. Software supply chain security is basically a way to secure a whole build pipeline, a whole build infra with the help of some of the security measures that we make sure to use. And this is why it matters, because as per the Gartner review, 63% of respondents have stated that in the past there has been some compromise, or they have been attacked by some bad actor or attacker, or they have compromised their AWS key or credential, which in return have impacted them to create a loss of revenue, or majorly a loss of revenue. And there has been like many past incidents with respect to software supply chain that are well known. Some of them is like Log4Shell and SolarWind. So SolarWind basically one of the recent attack which was happened 2019, where basically they had leaked the they had leaked the credential through which the bad actor attacker were able to get access to the system. And over a period of time, they basically push out the tainted code towards the customer, and 18,000 customers were affected by the bad actor's code, which in return got basically ran into a loss of revenue and another people's compromised architecture.
So we have seen that like the attacks are happening everywhere, right? And we need to make sure our supply chain is secure. So what can we do?
So this is the entire supply chain attack vector. Like these are the particular areas where your or our build infra can get compromised. Starting from injecting a bad code, it can happen from a developer or a bad actor, and then getting compromised into a source control. If a Git or a version control gets compromised, then there may be a unnecessary malicious code that can get pushed to a build system, which can in return basically inject some bad code or basically run some cryptographic libraries or mining attacks, and that can basically got built into a production, I can say, run pipeline and can ship to the customers. And dependency are the major corner areas which are more focused on getting compromised, because these are the most critical and fragile thing. If we in the recent event, if we see, if people over here are well familiar with Nginx, there has been 3 CVs which were kind of critical. It was been reported past week. So the 3 CVs, in the 3 CVs, we can say one of the CV, I can say vulnerabilities were like if any pod had access to the particular vulnerabilities, then the whole container can get compromised, and people were using that in production. And thanks to the KH community, we were able to resolve that. And this was like a prior step that they took and to resolve that particular thing. And if that particular vulnerabilities was not found earlier, then it could have basically created a huge chaos, I can say, into the bad actors' hand, and the whole build system can have been compromised.
Okay. So one of the main issues which is we don't know how the attack can happen, because if we know, we could have fixed it previously. That's why software supply chain comes into the picture as well. So if we move to the solutions, like, okay, we understand what the attack is, how it can happen, how we can prevent it, how we know that our dependencies are secure and we can implement it and push it to our customers. So we do have a couple of solution we have listed on our slide, but there can be more. And so it starts with CV scanning. Like, you can make sure that whatever dependencies you are using is not vulnerable. You can do CV scanning tools like Gripe to make sure they don't have any vulnerability. But it can be a little overhead for the developers to do that for each and every package. We also have artifact verification and artifact signing. So you can make sure that, let's say, if you are building something, you are pushing to your customers and they use that as a package, you can make sure that the package is artifact signed, your artifact is signed and verified using various other open source tools and authorized certificates as well. We also have a shift left. So shift left is one of also a practice in which you ensure you don't have any vulnerability in your software that you're building in the phase of SDLC itself. You make sure before pushing any software to your customers, it is not vulnerable and it is free of bugs and everything. So we have one more, which is SBOM. So SBOM is a software built of materials, which gives you a detailed information before using any dependency. Okay, what it made of, what other dependencies it is using, and who signed, and each and every information that you want to go. So let's say if we take an example, in London, I think beans are really famous. People love it. And if you check out the beans package, you will find information, what ingredients it is using, what kind of chemicals is used to preserve the beans, right? And this is how you make sure that you are eating something right. You are not eating which is bad for your body, right? So SBOMs acts similarly. SLSA standards is also a best practices which you ensures for your making sure that your application is not vulnerable. So we'll talk about SLSA. So let's talk about SLSA and start with it, SLSA. So
yeah, let's focus on SLSA, because the other three, like CV scanning, I can say artifacts verification, artifact signing, can be basically done with the help of other tools. But SLSA is one of the key framework that basically focuses on a few requirements that we need to make sure we are following so that our build system, or I can say the entire build system, is safe and secure. And these are they have pushed latest version 1.0, which basically suggests the build 4 build pipelines. First is build LO, build 1, build 2, and build 3. It's basically a list of a requirement of things that we all can basically implement around our version control and build system to make sure that they are following the proper security compliance to basically be well aware about, to be well secure about the things that we are doing. This is how basically SLSA helps. So considering the things like having two-factor authentication, making sure that 2 reviewers are there to merge your PRs, then considering that there is no pull request from anonymous person apart from the team. If your repositories are open source, making sure that it's a PR, there has been particular labels. Based on that, the GitHub runner can be activated, and that's how there can be not a DDoS attack over the GitHub Action workfolio. And then these are the whole lot of benefits that SLSA provides. It's one of the thing like security shift to left. It's like we need to make sure that whatever we are building is way more secure before pushing it to a production. So here also the DevOps principle, kind of the zero trust security principle, has been implemented. Then we enforce the provenance to build, and it's also end-to-end supply chain trusted. So basically following all the requirements and making sure that basically is implemented in the build system make us more secure and safe rather than getting attacked by any bad actor.
Okay, so let's talk about Sigstore and how you can use it for your software supply chain. So Sigstore have few components, and one is Record and Flushio and Cosine. So what you make sure that, like Yes explained, like you can make sure that your like the packages that you are using is signed and everything. But where you will find it? Like how can you make sure that, and how can you make sure your application is signed before other your customers can use it or anyone who is using your software? So in Sigstore, we have three components. One is the record. So whenever you sign your application under the authorized any authorized service, which can be a Flushio. So in this case, a Flushio can be an authorized service which uses cosign to sign your artifacts to ensure, okay, it is signed by authorized service or authorized vendor. And now all the logs of that can be stored in a record. So record is kind of a place or the database which stores the metadata of signed informations. It can be a public, or you can use record in your organization itself for internal purposes. So this is what actually Sigstore is. So let's move to the next slide, which is how the Sigstore works. So yes, please.
So this is one of the diagram, I can say architecture, where Sigstore tends to follow. Where developer with a proper cosign request signs the artifact. That particular artifact is basically signed under Flushio, which is a certificate authority. And then the data, I can say that transparency log are basically sent to record. So record is the place where we can go and check who all signed this particular artifact or from where this artifact had came from. This is a section where we can see all the logs with respect to any artifact that basically has been pushed by cosign. And that's how the whole build architecture, I can say the build package has been shipped to the customers. And if anyone wants to monitor, they can come back again to record and see the transparency logs and check whether it's to whom or who has signed that particular artifact and who has shipped it. So to making sure that the coming artifact to the customers or the consumers is been well signed and verified by a particular authority, and that's how the Sigstore works. Yeah. Now we come towards SBOMs. SBOMs are basically software bill of materials. To be in simple word, it's like a list of ingredients your software tends to have. So whenever you are working on a recipe, you make sure that there are few things or ingredients that tends to get added to the dish so that it's well rich with the taste and thing. The same goes for software. If we want to use a software, we should be well aware about what all things are included inside the software, considering from packages, from the images, or I can say the whole build infra. And that's where SBOM comes into picture. SBOM is a way, I can say, a place where we can get an end-to-end understanding about what all things or what all ingredients the whole software tends to have. And this is on the right, there is an example of how that basically works. So we tend to see who all basically signed this particular image or artifact, where it can be used, and what all architecture has been using. So it's a complete end-to-end description about whether you are using the software is coming from a valid source or not. And that's how basically the entire software supply chain lifecycle works.
Yeah. Do you want to show the demo or?
No.
Let's see. We were preparing for the demo, but I'm not sure if we should do that or not right now. But yeah, for now, that's all. Thank you, everyone. We have a slide. We have a QR code which you can scan and give us a review how you found this talk to be helpful. You can follow us on the Twitter. And thank you, everyone, for listening.
Any questions?
We are open for questions now.
Yeah, we've got a couple of questions over here.
Thank you for the presentation. I wanted to ask Yash, okay, the one who works at Chainguard, right? So how does Chainguard react to a new CV when it's out? Because I understand that Chainguard builds almost zero CV base images, right? So how do you react when a new CV is published, and what sort of process do you go through?
Over here, we tend to have a sustaining team. How it basically works is, whenever there is new CVs which is been generated, we tend to have a board system which is well verified with the things. And it's like whenever a CV has been detected, if there is a solution present, existing solution we tend to have, the bot tends to add the patch, and that's how the images are basically CV patch free. And if there is no solution for that, we tend to create our own solution. I can say builds pipeline is again created to basically fix that. And that's how we are able to sustain the whole CV-free images, and that's by following the entire software supply chain principles. Welcome. Any more?
No? Any more questions? No?
Don't be shy.
Well, fantastic. Thank you very much, Yash, and Yash, for an outstanding presentation. Thank you.
you.